Assalamualaikum and hi, we are from section 3, group 4. We will present about soil improvement using deep vibro-compaction technique. First of all, let's meet the team. First one is Muhammad Syafiq Ikhwan bin Razlan. Second, Muhammad Nuriskandar bin Mahadhir. Third, Qian. Fourth, Norellysha Fariha binti mohamad Norhisham. And finally, Norhana idayu binti mohamad hanapiah. Moving on to the introduction part, the usage of depth vibrator to increase the bearing capacity and settling poor soils has been around for over 70 years. Vibro-compaction technique is the oldest dynamic deep compaction technology in use. The technique was introduced by the Geotechnical company in 1936. The method aimed to increase the bearing capacity and stiffness of in situ, natural state or chemically modified soil. Compaction increases the shear strength of soils by adding friction from the interlocking of particles. It works by densifying the granular soils. Common uses of vibro-compaction includes reducing foundation settlement, increasing stiffness, increasing shear strength, and reduced permeability. And the study was conducted to prevent building from collapsing by deep vibro-compaction method.
The next part is literature review. The deep vibration compaction method is a deep compaction method for granular soil that reduces settlement and porosity while increasing the vertical bearing capacity of foundation. Johann Keller created the deep vibration compaction technique, which has been utilized effectively in practice in 1936. There are two primary methods for estimating vibro-compaction success. The first one is in situ method, and the second one is indirect derivation method. It is frequently used in road and airport building to compact the subbase and base courses of granular materials such as rock fill and sand, as well as in foundation construction to flatten the soil beneath shallow foundation. The advantages from deep vibro-compaction technique are offer an economical solution for ground improvement, environmentally friendly as use natural in situ material, extremely quiet with low vibration, and maintain original site elevation where backfill is used.
So, here is the methodology. A vibrator hanging from a crane is used to vibro-compaction to achieve the desired depth. Penetration is frequently added by water jetting. The vibration's energy minimizes the force that acts on the soil particles, allowing it to become more denser. The vibrator with power pack, a cross-shaped vibro ring, and a support ring, which is crane, balance out the vibro-compaction apparatus. The cross-shaped vibro ring is a cylindrical probe with two non-parallel steel plates. The vertical oscillation is caused by the eccentric weight at the top of the cylinder. There are some optimal vibration frequency that usually has been used. For seed clay, it is between 15 to 20 Hz. Second, for Sukia seed clay, is 17 Hz. When the tip is exposed to 360 kN centrifugal force, it moves around 2 cm. The vibro ring is lowered to required work depth at a rate of 2 meter per minute and subsequently elevated at a rate of 1.2 meter per minute.
Now, I would like to present about the result and discussion. The deep vibrator's three-dimensional movement is detected by its interaction with the compacted soil. While the soil stiffness increases throughout the compaction process, the vibrator movement changes. As a result, the vibrator movement, while taking specific process factors into consideration, may be used for a work-integrated indicator of compaction condition, which might offer the machine operator with useful information on site and be a helpful instrument for quality assurance of the compaction works. The settlement that occurs as a result of vibro-compaction might range from 5% to 15% of the compaction depth, depending on the initial density and the intended density. Figures besides shows a schematic of the step-by-step installation method of vibro-compaction. Vibro-compaction over large areas is often accomplished using a triangular or rectangular grid pattern with probe spacing ranging from 2 meter to 4 meter. The spacing is determined by a number of criteria including soil type, backfill type, rock type, and energy, and the amount of improvement required. In general, compaction parameter monitoring and post-compaction testing are the categories in quality management of vibro-compaction works. Throughout the building process, the compaction parameters, depth and power usage are monitored using a real-time computerized system. The recorded data is also printed in real time alongside the probe reference number, date, and time of compaction. This ensures that the work is properly recorded in order to verify that the required end result is obtained. Post-compaction testing is done to check that the standards are achieved. Sounding methods are commonly used to test the efficiency of vibro-compaction. It is possible to utilize dynamic penetrometer testing (DPT), standard penetration test (SPT), and cone penetration test (CPT). CPT is currently the most widely used post-compaction test. It is recommended to undertake post-compaction testing at least 1 week after the compaction activity is finished, so that the extra pore water is decreased to the pre-compaction level. Vibro-compaction techniques are most successful for sands and gravels with less than 15 to 20% particles. The figure besides shows the relationship between the particle size and the available vibro techniques.
Thank you and hi, I'm Ong Chen Hui. To summarize, vibro-compaction is the most effective soil improvement technique for loose sandy soils in reducing foundation settlements. It is used to support various types of construction projects such as embankments and chemical facilities. Since this technique does not produce spoil, it is considered as one of the most cost-effective and ecologically friendly techniques in increasing the bearing capacity. Due to the irregularity of its design and building procedure, the vibro-compaction technique should be applied with caution. It is recommended that experienced engineers should be hired to design this technique using subsurface parameter on site. Its installation should be strictly monitored by qualified professional engineer. With the suggestions made above, this approach can be regarded as the necessity for higher bearing capacity for further plant growth. That's all for our presentation. Thank you for your attention. Hope these presentations have enhanced your understanding regarding the deep vibro compaction technique in soil improvement. Have a nice day.